SAP ABAP-based software systems can trust other ABAP-based software systems. This makes it possible to set up a relationship similar to a single sign-on for RFC and HTTP communication between trusted systems and trusting systems. Here's a brief example where a trust relationship has been established so that System B will trust System A. And this means that System B is the trusting system and System A is the trusted system. This relationship enables RFC communication from System A to System B without any further authentication required, so no password is needed. Trust relationships are maintained in transaction SMT1. They can be used in transaction SM59 in ABAP connections and in HTTP connections to ABAP-based software systems. They can also be used outside of SM59 with dynamic RFC connections. Insecure use of trust relationships could allow malicious users to impersonate other users in remote systems without the need to know their password. This could be accomplished by changing the username in RFC destinations using a trusted system logon. And there are other ways this could be accomplished. Here are 7 common mistakes made with securing trusted relationships. Number 1, create a trusting relationship in transaction SMT1 with a system from a lower security classification. This means a production SAP system can trust another production SAP system, assuming they are classified at the same security level. But a production system should not trust a non-production system like a test or development system, assuming these systems are at a lower security classification than the production system, which is almost always true. Number 2, create a mutual trust relationship in SMT1 when only one relationship is required. The definition of a trust relation is directional. System A trusts System B, but not the other way around. Usually you don't want to create 2 mutual trust relationships for a pair of systems in a way that both systems trust each other. For example, an S/4HANA or ECC system may need to trust the Fiori system, but the Fiori system may not need to trust the S/4HANA system. Number 3, using outdated authentication methods. SAP has improved the security of the authentication mechanism that is used for trusted system logon. This improvement also helps address the capture replay vulnerability reported in January of 2023 with SAP Note 3089413. Number 4, not properly securing the table RFC sys ACL. This table stores the technical data on the trusted system connections and should be restricted by assigning the table to the authorization group TTRL. Users should not have access to display or change data on this table. This becomes less of a concern with the recent improved authentication mechanisms where the secret key that is stored on this table is now stored in the operating system. However, you still want to properly secure the table RFC sys ACL. Number 5, not properly securing the authorization object S_RFC ACL. This object must be limited in the trusting system and should never contain a wildcard asterisk. If it does, a warning message is displayed during the role maintenance if administrators maintain a wildcard for any of the authorization fields for this object. And we'll talk a little bit more about the different authorization field values for S_RFC ACL towards the end of this video. Number 6, adding the S_RFC ACL object to the SAP All profile. SAP purposely does not include S_RFC ACL object in SAP All or SAP New profiles because it's such a sensitive authorization object. So if it's been added to either of those profiles, the recommendation is to remove it. Number 7, not setting the profile parameter RFC self-trust equals 0. By default, a system will trust itself, which means there exists an implicit trusting relationship between the clients of a system. You can switch this implicit trust off by setting the profile parameter RFC self-trust equals 0. This is described in more detail in SAP Note 2449757. This concludes the list of 7 common mistakes made with trusted system security. Next, we'll spend a few minutes going through the S_RFC ACL object and the different options for maintaining the authorization fields. These are the different authorization field names for the S_RFC ACL authorization object. Activity, currently this field can accept the value 16, which is execute. RFC client, that would be the client number of the calling system. RFC same user ID, this is a flag, it's either yes or no, that indicates whether the user being called has to have the same ID in both systems. RFC information, this field is currently inactive. System ID is the usually 3-character system identifier of the calling system. RFC transaction code, here you can specify the T code that is making the call. And RFC user, this is the ID of the calling user. So you can essentially hard code the ID into the authorization object field value here. So to give you an example, if user 1 wants to execute a function module from client 100 in the system named S10, then, and they want to do this with their own ID, then that user would require the following authorizations in the target system. For activity, you would have execute or 16. The RFC client would be 100. The RFC same user ID flag would be set to yes, called by the same user as possible. RFC information, you can use quotes to just leave that blank. System ID, you would specify the S10 SID for the calling system. And for RFC transaction code and RFC user, you can essentially leave that as a null value or blank. So this concludes the video. If you have any questions or comments, please let us know. Or if you're interested in any of these other topics around RFC security, feel free to leave a comment below. Thank you.